Welcome back to Math 103. This is video number 6 on apportionment. Our task now is to find the Hamilton apportionment for the same example as before it, that is, the same states and the same populations, but now with 21 seats instead of 25. To do this, we need to recompute all the standard quotas. But don't despair, we've already done most of the hard work. So for Massachusetts, for example, we've already figured out that 0.4532 is its share of total population. So 0.4532 times 21 seats is what we now have to compute to find its standard quota. In other words, the 0.4532 here is work that we've already done. Remember where that came from. That was 6.3 million divided by 13.9 million total. So 45.32% was what we found was Massachusetts' share of the total population. Great. So 45.32% of 21 seats, that is 0.4532 times 21 seats, equals 9.52 seats. Great. So we can go on in the same way and compute the standard quotas for each of the remaining states. So when you add these up, with a tiny bit of round off, you get 21 seats as you're supposed to do. And from there, we can then fill in the lower quotas. So 952,110. Okay, so it is possible to have a lower quota of 0. So Vermont has a standard quota a little bit less than 1. Okay, so fine, rounded down, that becomes 0. So each of these is the standard quota rounded down. Next, we have to sum up the lower quotas in order to be sure how many surplus seats there are going to be. So we have already given out 18 seats. Think of this very concretely. Hamilton has gone around and already given each state its lower quota of seats to make sure that no one gets any less than their lower quota. That gives out 18 seats thus far, and now we have to decide whose decimal part is the highest. Okay, we're going to actually need the 3 highest decimal parts because we have 3 surplus seats. Right, 21 seats total, 18 already accounted for. The difference is 3 surplus seats that still need to be given out. Okay. So for Massachusetts, we have a decimal part of 0.52. For Connecticut, 0.14. For Maine, 0.12. For New Hampshire, 0.81. For Rhode Island, 0.51. And for Vermont, 0.91. Okay, and apart from a little bit of round-off error, when you add those up, they do indeed add up to 3. So what does Hamilton say that we should do? We need the 3 highest decimal parts. So Vermont has the very highest, New Hampshire has the second highest, and this is very close, but it's actually Massachusetts, which has the 3rd highest. Rhode Island is coming up just short here. So at the end of the day, it is Massachusetts, which got its original 9 plus 1 extra is 10 seats. Connecticut just got its original 5. Maine received 2 seats. New Hampshire, its original 1 plus 1 bonus. Rhode Island, just its original 1 seat. And Vermont, its original 0, but fortunately plus 1, equals 1 seat at the end of the day. And when you add those all up, you do indeed get 21 seats accounted for. There are 2 things worth pointing out here. One is that this was really quite close. Massachusetts, if you carry one more decimal place of accuracy, if you carry 3 decimal places here, its decimal part is 0.518, and for Rhode Island it's 0.511, so that's really, really close. Sometimes it's a good idea to carry a little bit of extra accuracy to make sure you're making the right comparison. Also, if you carry 3 decimal places of accuracy, then that actually gets rid of the round-off error here, and these decimal parts add up to exactly 3 seats. The other remark is that if we had rounded conventionally, if we had simply taken the standard quotas and each one was rounded to the nearest integer, so 9.5 blah 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 would be rounded up, 5.1 something rounded down, 2.1 something rounded down, 1.8 something rounded up, 1.5 something rounded up, and 0.9 something rounded up. If we had rounded in the conventional way, then actually Rhode Island also would have been rounded up, and it would have ended up with 2 seats, and then this total would have added up to 22 instead of 21. So this is an example where if you had done conventional rounding, you would have had 1, 2, 3, 4 bonus seats, and that would have meant actually that the wrong number of seats in total would have been apportioned. Right? So you can't rely in general on just computing standard quotas and just rounding conventionally. You really do need the rest of this process. This brings us to a couple of important follow-up questions. We can ask how many people live in each congressional district in New Hampshire and how many people live in each congressional district in Rhode Island. So in New Hampshire, we had 1.2 million people spread out across 2 congressional districts. Well, 1.2 million people spread out over 2 districts is 600,000 people per seat, okay, or per district. I'll write here 600,000 people per seat. By contrast, Rhode Island had 1 million people living in just 1 district. So 1 million people, as it were, spread out across 1 district, and that makes for a very different situation in Rhode Island compared to New Hampshire. Right? In Rhode Island, it is a whopping 1 million people per seat, by contrast with the 600,000 people per seat in New Hampshire. Great, so now to see if we really understood, if one of these 2 states complained about unfairness of the apportionment, which state would it be and why? Now think about that for a minute. Who is getting a good deal here and who is getting a bad deal? Rhode Island with 1 million people per seat, is that good news or is that bad news when they look over at their friends in New Hampshire? Well, I claim that Rhode Island would complain. Okay. So Rhode Island would complain that it has a more crowded congressional district. That's a way of thinking about it. Right? They have 1 million people all vying for the attention of 1 member of Congress, whereas in New Hampshire, you have less competition to get the attention of your representative. Right? There are only 600,000 people sharing 1 congressional representative. So the districts in New Hampshire are less crowded than the ones in Rhode Island. So arguably, each individual resident in Rhode Island has a little bit less of a share of a role in Congress than their friends in New Hampshire. Before going on to the next video, think about the next question and try to answer it. It takes a little bit of thought, but it's not so bad. Can Hamilton's method ever violate the quota rule? Or does it never violate the quota rule? This sounds a lot like the kind of language we used back in the chapter on voting methods when we talked about violating or never violating a fairness criterion. And that's really what this is. We're asking, can Hamilton's method ever possibly create a situation where someone received less than their lower quota or more than their upper quota, or can that not happen?